Now in this video we will solve exercises of the book that belong to continuity subject. To check the continuity of the function, we will use the limits. Take the limit from the left for g of x and the limit from the right for g of x. So now L1 for g of x, we will substitute instead of x 3 and the result is 6. Even in L2 we will substitute x and the result is 6, so L1 and L2 are equal. The continuity wants to check the function itself, which is now g of x equal x plus 3. That's why we took g of 3 and substituted 3 and then the result is 6. So the limit of the function is equal to the function itself at x equal 3, and that's why g of x is continuous. Again, with number 2 we have h of 2. This function is defined as t squared plus 3t minus 9 over t minus 2. Again, I have denominator, and my value in the denominator that will make it 0 is 2, which is here h of 2, the critical value or the crucial value. So how can we check to make it continuous? We will take the function h of t and write it. Then we will factor the trinomial in the numerator. After factoring, we found that it's possible to remove a common factor up and down. So the result is t plus 5. And now we can substitute instead of t the value of 2. So now, to check the continuity, we will take the limits left and right as h of t equal 2 plus 5 and 2 plus 5, the result is 7, they are equal. And then we will substitute it in the main function h of 2 equal 2 plus 5, and it is 7 also, so the limit equals the function at t equal 2, and then the function h is continuous at t equal 2. Now on exercise 3 we have the function f, and we want to use the continuous extensions to be continuous on s equal 1. So now I have the functions formula. I write it. After writing the functions formula, we will see that we have difference of 2 cubes in the numerator, so it will be factored easily. And in the denominator there is difference of 2 squares, and it will be factored easily. And after factoring, we will find that there are 2 common factors. We can remove them. So then the result is going to be simple, and there is no problem with the denominator. So now this is my function. I will take the limit from the left and from the right. This is L1 from the left and L2 from the right, and here are the functions formula, and when substituting instead of each s we will put 1. So the result is 3 over 2 for both. That's why L1 and L2 are equal. Now on number 4 we will define the function g, which is given as fractional value also, and it is x squared minus 16 over the triple terms or the trinomial x squared minus 3x minus 4. So to be solved, we need to factor the numerator and the denominator. This is x minus 4 and x plus 4, and the denominator is going to be x minus 4, x plus 1, so x minus 4 is going to be removed from both sides, and the result is x plus 4 over x plus 1, so the problem of denominator 0 has been removed. That's why we can directly take L1, limit from the left, L2, limit from the right, and we find that the value of them is the same. So L1 and L2 are equal, and we take g of x, substituting the value of x, which is 4, in the function after simplifying. So the result is 8 over 5. Now the limit equals the function at x equals 4. So the function g is continuous at x equals 4. On number 5, we have a function f of x, which is a piecewise function. This function is continuous at every x. What we need to know, if this function is continuous at every value for x, what is the value of a? So how can we know this? We first need to use the continuity conditions. The continuity condition says that we can find L1 and L2 since the function is continuous, so they are equal. I'll take the limit for the function as x approaches 3 from the left and from the right. So from the right, as x greater, so it is 2ax. And as we know, we substitute the value of x, so the answer is 6a. And that's the most thing we can do. In L2, x from the left approaches 3, so the value of the function x squared minus 1. And when you substitute instead of x 3, this is 9 minus 1, 8. As L1 and L2 equal because the function is continuous, so 6a equal 8, and then the value of a is found. On number 6, the function g, also a piecewise function, and it is continuous at every x. We want to find the value of b. Okay, now L1 and L2 will help us to find the value of b. So L1 is the function, the limit of the function as x approaches 2, negative 2. This negative 2 is from the left. So x approaches negative 2 from the left, and this is the result. Then from the right, as x greater, so this is the value of it as bx squared, and the value is going to be reached. Now L1 and L2 are equal since the function is continuous, so we equal them and then find the value of b.